Okay. All right. I really want to rock up through this. It doesn't require a lot of work to be done. It requires understanding a concept or two. So even though you have an outline on the very first page of your notes, and even though that outline has pages from your textbook written in it, I don't know how much I'm actually going to assign to you because I trust you guys are smarter than the average bear. Okay? So I may very well not say, okay, do these pages. But you may want to do a question or two to keep up. Picking up what I'm putting down, read my mail, mowing my lawn? All right. Let us get down to business right away. Anything I highlight is a word that you need to understand. A set is a collection of information. And in math, we call information, depending on if you're American or Canadian, data or data. I will use them interchangeably. Why? Because sometimes I like it when you say data, and sometimes I like to say data. Neither one is right nor wrong. I just like saying them in, certain ways. All right, that is what a set is. So, for example, in this room, I can think of four different ways to group the people in this room into sets. Because a set is a collection of any information. What do you think one of those sets would be? Gender. Excellent. That's one. There's men, there's women. Good. What else?
Glasses.
Ooh, glasses. Didn't even think of that one. Height? What? Hair color? Eye color? Students and teachers? There's a million ways we could do it, yes? The point is, it is a collection of information, data. That looks like an S, but it's supposed to be an arrow. That one can count. If you can count it, it makes a set. Everybody cool? Easy peasy, lemon squeezy. All right? So I'm going to do an easy example. An example is students in here. Cool? You guys are a set because I can count you. And I am not a member of that set because I am not a student. Got it? Unless I do that weird sort of airy-fairy Jedi ninja thing. I'm a student of life and I will be a student forever. Blah. Whatever. Okay? Everybody with me? Okay. An element is a single... What is wrong with my printing today? You can tell I haven't written in 2 weeks. A single... That's better. Item from any given set. So an example of that would be Danielle. Okay? She is a single member of that set. Am I an element of this set? No. Am I an element of another set? Yes. Are you an element of the set I am in? No. Got it? Now I'm going to change it. Now the sets are men and women. Is Anthony in the same set as me? Yes. Is Danielle in the same set as me? No. Is Danielle in the same set as Anthony? No. Anthony, I knew whoever I chose, somebody was going to be like, he's not really a man. I know. I'm sorry. I knew that I was throwing somebody to the wolves. You just happened to be close. And I knew there would be meatheads in here like, you're not a man. I know. I get the joke, right? I'm sorry. But on the plus side, you're in the set with me now, and our set rocks. So, right. Not that your set is not rocking. Huh? Both sets are equally rocking. Unless you watch American network TV, and then, of course, the women's set is far and away the best. All right, so, okay, now, a relation, now this is key, is any association, any association of elements from one set to another. So keeping with this example we have here, the sets are students in the room, yes? Next door, there is another set, yes? Because there's students in there and there's a teacher in there. Are you with me? Okay. If we were going to make up a relation, then what you would do is you would go next door and sit beside one member of the same set as you. Could any of you go in there and sit with Mr. DeVries? No. Can anybody in this room go in and sit with Mr. DeVries? Yeah. Who? You. Right. Everybody with me? Okay. So everyone's cool with that? And the example is, you go sit by a kid next door. Everybody cool? Yeah? Okay. Let us move it along. Here we have a graph. You guys all know how to make graphs, so I'm not going to waste time explaining how to make graphs. You've all made many graphs before in your life. Graphs have titles, graphs have scales, all that stuff. I'm not going to waste time on that. I trust that you know that. Okay? However, what I am going to discuss here is the two different sets of information shown on this graph. What are they? Set 1 is what? Breed of dog. Excellent. Breed. And set 2, what's the other piece of information that is being counted? Height. Excellent. Ease bees, lemon squeezy, right? Okay. So now you're going to learn something new. You know those squiggly arrows that you guys used to make devil horns back in the old days before emoticons came out? Well, you guys know this, colons, bracket, smiley face, right? But now, of course, nobody does that because now there's emoticons. Or emojis, I mean. Back in the old days, you had to do these. I did this one all the time. Squiggly bracket, number 8, and then a smiley, that bracket, because that was my hair with glasses and smiling. That was my emoticon of me. Anyway, in math, we use those brackets in set notation, what is called set notation. So the breed, we would list it out. You can be a hound, and I'm going to start shortening it because I'm lazy, a Chihuahua, a Corgi, a Lab, a Shepherd, and a Malamute. If you don't know what any of those dogs look like, it doesn't matter. But I'll tell you real quickly. You know what a hound is, you know what Chihuahua is. Chihuahua shouldn't even be on there because, of course, Chihuahua is not a real dog. Corgis are those little dogs that look like Labs but have no legs. The Queen has Corgis, yeah. The Queen loves the Corgis. A Lab, you all know what a Lab is, you all know what a Shepherd is. A Malamute's a big giant dog, looks a little like a Husky. Okay? Done. Now, that is set 1. These guys are the elements of that set. Cool? All right. What are the elements of height? 60. 12, sure, then 30, then 45, then 45, then 80. Everybody cool with that? So right now I have 2 sets made up of individual elements. Everybody good? Now, do I have a relation yet? Do you think? Remember, a relation is any association of elements from one set to another. Do I have a relation? Yes, I do. Scarlett is nodding. Why?
Because they're connected, like the height of one.
Every dog has a height,
Yeah.
right? So I have a relation. I am relating the heights to the dogs. Everybody with me? So if I say to you, how tall is the average Malamute? Can you tell me? Yes. 80. Whatevers. Centimeters, inches, whatever. It's not labeled, but 80. 80 units tall, right? What dog averages 12 units tall? Chihuahua. So we have a relation. Everyone understand? Because every dog has a height, and every height has a dog. Cool? But there's a problem here, isn't there? Where is the problem?
The lab and the shepherd.
Lab and the shepherd. I have a 45 unit tall dog. What kind of dog do I have? What? I don't have two dogs. I told you I have a dog. What kind of dog do I have? You don't know. Understand? I have a lab. How tall is he? Sam has a shepherd. How tall is he? That's fine. Works fine, doesn't it? But going the other way, it doesn't. Everyone understand that? Okay. So this is what we call a relation. Because the elements of set 1 go with the elements of set 2. Is everybody good with that? Everybody's got it? Just like you guys all have a height and a weight and an age. All that stuff. Got it? Everybody okay? All right. Turn your page over because we're going to make a slight change now. New word. A function. What's a relation? Any association between two sets. Any association is a relation. But a function is a specific relation. A specific relation whereby one element is associated with only one element in the other set. Okay? So, think back to the dogs, we just talked about them. Is it a function? No, because the type of dog, lab and shepherd, are both associated with 45 as a height. Is everybody cool with that? That means that is a relation. It is not a function because they share that 45. Is everyone cool? All right. So let's have a look at these three examples and see if you guys understand, or two examples. Do you guys have three or two? Okay. Every month of the year relates with the number of days. Is that a relationship? Yeah. What is the first set in that scenario? Set 1 is month. And set 2 is days. Right? Does every month have days? Yes. So it's a relation. Everyone agree? Is it a function? What's the first month? January. How many days does it have? 31. One element relates to one element. Is it a function right now? Yes. What's the next month? February. How many days does February have? Or 29. Is it a function? No. Why? Because there's two elements that associate with February. Okay? Now, what if it's not a leap year? This is not a leap year. 2017 is not a leap year, yes? So February's got 28 days in 2017. Are we a relation or a function now? We're back to function, aren't we? Okay, what's next month? How many days in March? 30 days has September, April, June, and November. All the rest have 31. 31, relation or function? Now we're back to a relation because January and March both equal 31. So Taylor, if I say, hey, what month has 31 days? I'm thinking of a month, it's got 31 days. You know what month I mean? No. So therefore it can't be a function. Got it? Everybody good? Okay. So this is no, it's a relation. Why? Same element in set 2 for more than 1 in set 1. Everybody cool? Okay. Every name on my class relates to a student. Every name on my class list relates to a student in the class. Do I have 2 sets of information there? Yes. What is set 1? Name. What is set 2? Kid. Everybody agree? I get a class list before I met any of you. I knew none of you. Right? I didn't know any of you when I got the list. I didn't know any of you who were anybody. I mean, I recognized some last names from previous kids I taught, right? Maybe you're a brother or a sister or a cousin or an auntie or an uncle or a pet rock. I don't know. But I had a list of data, and I know that every name on that list relates to one kid, right? Okay, so relation or function?
Function. Some kids have the same name.
So this gets a little hairy, doesn't it? Okay. Sam Chapman. If I go by whole name, is it probably a relation or a function? It's probably a function. It's very rare I'm going to get another Samantha Chapman in my class, right? What if I go by first name? More likely it's going to be a relation. More likely. I mean, how many times have you been in a class with Tammy C and Tammy B? I'm sure. For Ethan's? Yeah, big surprise.
In our band class, those 3 Sam.
So, but that's what I'm saying, right? What about last name? Definitely it's going to be a relation, right? Think of this school. How many Mans are there? Right? How many Audulas are there? How many Gills? Yeah. Right? So if we went by first name only, it's likely a relation. Likely. There's a decent chance there's going to be more than one kid with the same name in the class. Right? If we go by last name, in our school, it's almost always a relation. Right? Is it a relation in this class? Do we have anybody who share last names in here? I can't remember. Yeah. So right away we got a function, right? But if we go by both names, it's most likely a function. Now, I used to say that it's always a function, but of course that's stupid because one year I taught 2 girls who sat right beside each other who had the exact same name. It's like Jazz Reet something or Jazz Preet. I can't remember exactly what it was. A couple of years ago. There's 2 people with exactly the same name. And they wouldn't sit apart from each other. I was very angry. Same last name too. That's what I mean. Exactly the same name. Even same middle initial. I'm not joking. No, they did not look similar. All right, so everybody is good with relations and functions? You can all tell the difference? You're cool? Okay. All right. Now, Every graph Okay. I let everybody have a few seconds there. Back to business. Every graph that you face has two variables on it. Two things that can change. Now somebody will say, oh, a lot more than two things on a graph. You're absolutely right. But every time you see a graph with like 7 lines on it, each of those lines is comparing the same two variables. Do you understand what I'm saying? Even when you think back to those socials classes where you got the graph that looked like this, it had precipitation with bars, and then it had the red temperature line. Even those, you're still only comparing two things, aren't you? You're comparing a month, June, to a temperature, or you're comparing a month, June, to a level of precipitation. You're still only comparing two things. Everybody with me? Okay. So let's, now that that's out of the way, we can talk. Ah! Ah! What has happened? Oh. Okay. I like how that recorded. Ah! All right. So those two things are always the dependent variable and the independent variable. And I'm highlighting them because I'm going to use them all the time. A dependent variable. What does dependent mean in English? It relies upon something else, right? Most of you right now are dependent on other people for your survival. Somebody is providing you with food, shelter, clothes. You may not like it, and it may not be true of all of you, but most of you are depending on somebody else for your food, shelter, and clothing. Yes? Am I? Yeah, who do I depend on? Who said that? I depend on the school board. Right? If it's not for the school board, I don't have the money for food, right? Everybody with me? Okay? My wife has a job too. Now my wife, by choice, depends on me to get dinner because my wife does not cook. Okay? So the dependent variable there is her. Now, rumor has it, according to my wife, last night as I was making the bed, I was making fun of her because last night at 8 o'clock, I made tonight's dinner and put it in a crock pot. And I was listing all the stuff I'd done, how I'd been to the store and made the stew and blah, 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 blah. And I was like, and you crushed candy. She crushed candy and she watched tiny houses. I don't. But anyway, so then she said, you know, I've been known to cook, sometimes even whole dinners. I'm like, oh, wow, I'd like to see that. She said, no, you wouldn't. You couldn't handle it. You would be all up in my face. You wouldn't let me sit down and let me cook dinner. Yeah, you're probably right. Another story for another day. So, dependent variable, or a dependent thing in English relies upon something else. So a dependent variable relies upon another variable. That's all there is to it, okay? So, a dependent variable is any variable. And remember, a variable is anything you can count. Any variable whose value depends on another. So, if I only have one variable, can it be dependent or independent? It can be neither, right? If you only have one thing you're counting, it is not dependent on anything else, is it? Okay, everybody cool with that? And this guy, I abbreviate him as DV. Okay? I also call him the output. Because you don't know what that's going to be until you know where you start from. Everybody with me? All right, now the independent variable, must be what? Yes. Any variable that has its own value. And we're going to do examples of this in a minute, and I'm going to explain it to you. Okay? And I abbreviate that as IV, and I call it the input. Okay? And don't worry about it. I haven't explained it yet, so stay cool. Okay? Some of you may already know it, and that's fine. Now, those two terms, dependent variable and independent variable, have sets, right? An independent variable, if there's more than one thing you are counting, then it has more than one element, right? So an independent variable is, dependent, we're doing dependent first, links up with the range, and the independent variable links up with the domain. And all that is, the domain is just the set of elements that make up the IV, and the range is the set of elements that make up the DV. Okay? So the independent variable and the dependent variable are the actual thing you are counting. The values of those things are the domain and the range. Everybody got it? Everybody cool? Everybody's good? Okay. We're going to talk about a graph that in a minute, but first I want to make sure you understand what I am speaking of. So, you can tell by the next question how long ago I made these notes. Sandy's getting a job at Flying Wedge Pizza. There isn't even a Flying Wedge Pizza in Abbotsford anymore. It's too bad, it was good pizza. Secondly, she's being paid $9.50 an hour. Hasn't been $9.50 in a long time. I don't even know what it is now, $10.25 or some crap? $10.45? You people are living like princes. You know what my minimum wage was when I started? $4. $4! When you were under 18, when you turned 18, they felt you needed 50 cents more an hour to live. 50 cents more an hour. So if you worked an 8-hour shift, you earned $4 extra. That was apparently the difference between living at home under 18 and living on your own. $4 a day. Huh? Everything was cheaper back then? Yeah, okay. It's not like I'm your grandfather where a nickel got him to the movies and popcorn and took a girl and bus fare and he still had change left over. All right, so here we go. What are the two things that Sandy is counting in her job? Hours she works and how much she's paid. Everyone agree? So my two variables, the two things that I can count that I can change are hours and wage, right? One of them is independent, one of them is dependent. Which is which? So Scarlett is saying independent is the hour and dependent is pay. Why?
Because however many hours you work equals how much you get paid. So if you get paid an hourly rate and you work 5 hours for $10 an hour, then you get $50. But if you work 6 hours, then you get $60.
Okay, so Scarlett is saying how much you are paid depends upon the time that you spend at the job. Does everybody agree with Scarlett? And I'm not saying if it's right or wrong, I'm just trying to get a feel for things. The IV, according to Scarlett, is hours, and the DV is her pay. Does everyone agree with that? And of course that is true. Because right now, are all of you passing hours? Are you being paid? No. So, is that variable independent of everything else? Yes, because you are passing time right now, but you are not being paid. Do you understand what I'm saying? If it is shared between everybody, it's independent. Hint, hint, time is almost always independent. because time is always passing. Do you understand? Now somebody will say, well, Mr. Myers, if I got paid $95, of course I worked 10 hours. No, lawyers get paid $95 in 1 hour. Oh, is it? When my wife comes to her senses, I'll send her to you for the divorce lawyering. No. Yeah, you will have me. That's why I'm sending my wife to you. 3 people get the joke. Anyways, everyone's okay with that? Everyone understands why that's the IV and that's the DV, yes? Okay, now I want to know the domain and the range. So the domain is the set of the independent variable, yes? So what is the lowest value of time that I can work? Really? Was I at work yesterday? Did yesterday pass? So what's the lowest amount of time I can be at work? 0. Excellent. Now, in reality, time never stops, does it? Milliseconds, picoseconds, nanoseconds, right? Down. But in reality, how many of you have jobs right now that you are paid by the hour for? How are you paid? If your shift ends at 5 o'clock and you're there till 5:05, are you paid for that 5 minutes? You are?
Yeah.
That's a very nice boss.
8 hour minimum.
That's a very nice boss. Where do you work? Yeah, you. Okay, and how are you paid? Up to the hour? So if you're putting the last 3 screws into a countertop and you go past 2 minutes past work, you're not paid.
Well, I can take my time and add so I can have 15 minutes.
And keep adding it on until you get to another hour. So you are paid per hour, right? You can add time up to get to another hour, but you are not paid for any period of time less than 1 hour. Who else? When I worked at Subway, the lowest they would pay was a half hour. If you didn't get up to a half hour, you weren't paid. And they didn't let you add it on. I had a bad manager. Everybody cool? You work at Subway, Navneet? How do they pay you? By the hour. What if you're working at 11 to 7, there's a huge lineup out the door, somebody asks you to grab 2 more bins of tomatoes on your way out at 7:03. Would you get paid 3 extra minutes? Of course not. Picking up what I'm putting down? So in reality, we're paid by the hour, yes? So what is the next possible value that I can have in my domain? 1. And what's next? Up to what amount in BC? You can go over 8 hours. There's all kinds of weird rules to get out of it. But for our arguments, we'll consider 8 hours regular pay. Everybody with me? Because once you go past 8 hours, you get paid overtime. Essentially. Yeah. There's a bunch of crazy rules about it.
One of our truck drivers.
Yeah. There's a bunch of, it's actually 40 hours a week. So that's how they get away with nurses and people working 10 hours and 12-hour shifts. 4 12 hours in a row is 48, but then you get the next 4 days off. So in any 7 days, there's all kinds of ways around it. But for math class, this is easy. I'm going to say this. Everybody cool? Okay. What then is the range? If I work 0 hours, how much am I paid? $0. What is how much am I paid if I work 1 hour? $9.50. 2 hours? $3 hours? $28.50. And so on and so on and so on. Why am I going by 9.5 chunks? Because that's how much you get paid per hour, yeah? Function or not? Function. Why? Right. Every element, no, I'm not going to say element. Every input equals 1 output. Because as Elma says, the only way I can earn $28.50 is by working 3 hours. If I go over 3 hours, I earn more than $28.50. If I go under 3 hours, I earn less than $28.50. Got it? Okay. What about the next one? Wait a minute, Mr. Myers. What is that? What does that construction mean in the 9th grade? Dots? Coordinates. This is a graph, yes? What goes first? X. What goes second? Y. If I asked you to find that point on a graph, where would you start? You would start in the middle at 0, 0, and then where would you go? You'd go 1 to the right. You would input your X first, wouldn't you? Which means, what then do you think is independent variable or input? It's X. X are the IVs, X's are the inputs. Y's are the DVs, Y's are the outputs. Cool? So what then is the domain of this set? All the X's. What are they? 1, 2, 3, 4. Everyone agree? Yeah? Okay, what is the range? 3, 6, 9, 12. Function or not? Function. Why? 1 output for every input. 1 goes to 3 and only 3. Got it? Everyone cool? Okay, you do the next one. I'm going to change color. D, R. What's the domain? Who would like to offer it up here? 1, 0, -1. We don't need to write 0 again because it's only one value, right? What's the range? 0, 1, -1, correct? Function or domain? Function or relation? Why? 0 goes with +1 and -1. Right there and there. Does everybody understand? The input of 0 gives, I just spelt it with a Z, I'm 50 cent, gives 2 outputs. Hey, how many of you guys going to go to that old school rap tour? Like Vanilla Ice and Tone Loc and Rob Bass and DJ Easy Rock and all the people that were on Pitbull's little show on New Year's. It's coming to Abbotsford. All the old school rap. None of you? Good. They're all older than me. But still cool. Okay, so you guys do C. What's the domain? What's the range? And then tell me if it's a relation or a function. What's the domain? What's the domain? 2, 4, 6, 8. What's the range? 3, 5, 7, 9. Function or relation? Why? 1 input to 1 output. Is everybody cool? What's different about D? It's on a graph. Is the graph still made of X's and Y's? Yeah. So I want the domain. Where do I look for domains? X or Y? X's. So my domain I'm going to do in red. Is there an x value here? Yep, because there's a dot. Everybody cool? Is there an x value here? Yep. Is there an x value at -1? No. Is there an output at 0? Yeah. Is there an output at 1? Yep. Is there an output at 2? Is there an output at 3? So what is my domain? -3, -2, 0, 1, 2, 3. Does everyone see how I did that? I'm only looking at domain, so I'm only looking at the x-axis right now. Is everybody cool with that? So when I'm looking for range, what's the only axis I'm going to be looking at? Well, the y-axis. So I'm going to do that one with green, or with blue. No, green, because it's already in blue on my screen. Is there an input at -3? Yep. What about at -2? Yes or no? Yep, because there's a dot right on there, right? What about -1? What about 0? Yep. 1? Yep. 2? Yep. So my range is -3, -2, -1, 0, 1, 2. Is everybody cool with that? Why did I have to put commas here? Because what? It's one number. Is there any output or input between the dots? No. So I have to keep them as separate elements. Everybody cool? Now, is it a function? Or is it a relation? One person has said function. 29 other people have said nothing. Now, a few more people have said relation. It is indeed a relation. Why? Because when x equals -2, how many outputs do I have? Does everybody see that? I have an output there, and I have an output there. If I tell you go to -2 and put the dot on it, do you know which of those dots I am speaking of? No. But if I tell you every other number, you can put the right dot on, can't you? Everybody with me? Okay. The vertical line test only works on graphs. Okay? And it is to tells if you have a function. And here's how it works. A straight vertical line can only hit one spot. At any given time. Okay, I'm going to let you write that down. I am going to go back to the previous page. I don't want you to, and I'm going to show you what I mean. Everybody cool? Here's what I mean. I'm going to erase all the dots I've put on this graph. I'm going to draw a straight vertical line. Oh, as straight as my shaky old man hands can draw. Everybody cool? I got my straight line there? I'm going to slide it along the graph. How many dots does it hit there? 1. So at the input of -3, I have 1 output. Everyone agree? What happens here? I hit 2 dots. At -2, I have 2 outputs. Therefore, this can't be a function. Got it? It only works on graphs, and it only works with a vertical line. That's why it's called the vertical line test. Cool? So you guys take that knowledge, look at the next 3 graphs that I have given you, next 2 or 3. You should have 3 graphs. Should go to the next page. You have 4, even better. Function or not, and then tell me the domain and range. Yes or no, and then a domain and range. Let's just do the first one. Okay, so is it a function or is it a relation? It is a relation. Why? Right. X equals -1. That gives me an output. Y is both 1 and 3. So it's a relation right here. Everybody cool with that? Okay. What is the domain? Domain I will do in red. So, domain, am I looking at the x or the y axis? Just the x. So there's one right there, 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 and there, and there. So the domain is what? -3, -2, -1, 0, 1, 2, 3. Everybody cool? Okay, what's the range? Am I looking at the x or the y axis now? Just the y-axis. -2, -1. There was 1 at 0. 1, 2, 3. -2, -1, 0, 1, 2, 3. Can everybody do function or relation and domain and range with dots? Is everybody good? Yeah? Okay. Take that knowledge that you have, look at this situation, and see if you can apply it. First thing, is it a function or not? Yes, it is a function. Because if I take my straight vertical line and I truck it along the graph, how many times does it hit the graph at any given moment? Once. Everyone agree? It's even animated for you because I believe in being a full multimedia presentation. Everybody cool with why it's a function? Okay, now you have to think. The domain is which? X or the y-axis? X. So, when we count on a graph, when we read a book, where do we start? On the left or the right? Left. So we're going to go all the way over to the left, way over here, and there is our first input, isn't it? Everyone agree? Okay. What is that input? -3. Now, are there inputs all the way along? There are, isn't there? So it's not -1 and -2. It's also got -2.9, doesn't it? And -2.35. And -2.31179. Right? So can I put the commas now? No, because it's everything, isn't it? So now my domain starts at -3. Do I make it to -3? Think back to grade 9. I have a dot there that is colored in. Do I make it to -3? Yes. So -3 is lower than or equal to all of my x values. Agreed? What is my biggest x value? Positive 3. So x must also be lower than or equal to positive 3. Does everybody see what I have done there? If you read this to yourself in English, negative 3 is less than x, which means every single number I have has to be bigger than negative 3, right? But x is also less than positive 3. So every number has to be less than 3. Is everyone cool with that? Does everybody see the difference between, oh crap, the one up above it that was all commas and this one? What's the difference between the two graphs? This one is a line, so it hits everywhere. This one is dots, so it doesn't. Everybody got it? Now, we're not quite finished writing this. We put a line, and we write domain, then we write this funky E, and an R. That R stands for real numbers. I'll do this differently. And then we close off the set. The R stands for real numbers. Remember, we talked about that last unit, right? That means everything. All the fractions, all the decimals, everything. Got it? So what then is the range? Where do you think we start counting? At the bottom or the top? We started counting on the far left for x's, so where do you think we start counting for the y's? At the bottom. Right here, correct? What is that? Negative 2. Did I make it to negative 2? Because the dot is colored in, yes? Is there an input for every number up to here? Now, range messes kids up because some of them want to stop here where the graph ends. Is that allowed? No, because the graph goes higher than that on the range. Does everybody see that? Blue is very hard to see. Maybe I'll change that color later. Or I'll make it thicker. That one. That one. That one. Okay. Is that better? Okay. So what then is my range? Negative 2 greater than or equal to what? Y, which is less than or equal to 3. And do I hit every number, including decimals? Yep. So the range is a set of real numbers. Can everybody understand that? I haven't given you a chance to do it yet, but do you all understand the basic theory behind it? If it's dots, you got to use commas. If it's a line, you got to use these things. Everybody cool? I'm going to show you another way to write this in a second, because that's big and ugly, right? I'm going to show you a tidier way to write it in a second. This is what we call set notation. And that uses the greater than and less thans. Everybody cool with that? On your outline, if you're following along with your outline, you're going to look at some stuff in the book. Right here is where you would do page 270, number 5, 8, and 9. Right there. Okay? Everybody cool? Okay. Because of time constraints, I'm going to go on and show you the other way to write domain and range now. Okay? Turn your page over. Tell me what's different about C. There's 2 separate lines. Okay? Do you think any of the other rules change? No. My domain is still going to be what? X's or Y's? X's. So where do I go? Which axis? X-axis and left or right? Start at the left. I get to right there, correct? It's a closed dot. So is that included? Yes or no? Yes. And what is that value? Negative. Look closer. Negative 30. See how it goes up by tens? Okay. That 30 is included, correct? So negative 30 is less than, or don't write this down. Actually, stop, because I'm going to show you guys the new way right now. This is the way you know. Negative 30x. Now, I go up to there. That's an open dot. Is the negative 10 included? Think back to grade 9. You guys all graphed inequalities in grade 9. Elma is shaking her head because Elma's right. It is not included. So there is no equal sign there. Is everybody cool with that? That is one set of my domain, isn't it? But what happens when I get to 0? Does it start again? Yeah. So there's another set of my domain, which is 0. Is 0 included? Yep. So it's less than or equal to x. And it goes up to what? Positive 30. Is positive 30 included? No. So I have two sets here, don't I? Does everyone agree? I got the first set right there. I can see it. It's colored in. I had a second set right there. It's colored in, correct? So what we do in set notation is we would write a big U there. Because they are together. They are included. If they weren't included, we would flip the U over. But you're going to do that next year, so I'm not worried about it. Everybody good? That's yucky and ugly, correct? Now, here's what you're actually going to write. The other way to write these is what we call interval notation. And it only works on lines. You can't use this if you only have dots. Everybody with me? And this is how you do it. Negative 30 is the lowest. Negative 30 is the lowest. And it is included, so we put a square bracket by it. It goes up to negative 10. Negative 10 wasn't included, so we put a round bracket. Everybody with me? So now that you've seen that once, it unions with what would this one be? Round or square bracket to start? Square bracket, because 0's included, comma. Then what? 30, and what kind of bracket? Round. Got it? Everybody cool? Now try it with blue on the range. Look at your range, look at your axis, and see if you can write out the range in interval notation. Start with your lowest range and check for circles. All right. Who would like to tell me what the lowest part of the range is? Negative 2? Negative 20. Is negative 20 included, Sam?
Yes.
Yes, so it's a square bracket. Where does that part of the range stop?
0.
Is 0 included?
No.
No. Round bracket. Union. What's the next one?
10.
10. Is 10 included?
No.
No. Up to what?
30.
Is 30 included? Yes. Can everybody do that? Everyone cool? Now, notice when I use interval notation, I didn't have to say if it was real numbers or not, did I? Because interval notation is always all the real numbers. Cool? All right, you guys try to do D. D is tricky because I also want you to tell me, is it a function? Yes or no? And then I want the domain and the range. And then I'm going to talk for like 1 more second. And then you're going to be done. And you can do as much or as little of the homework as you wish. You really don't need to do any. If you understand this, you're good. We have 10 minutes left in class. We shouldn't have too much trouble here. Okay, is it a function, yes or no? Sam says no. Scarlett says no. Danielle says no. Manrup says no. Bill says no. Why? Of those 6 people that had the backbone to tell me it was not a function, why? Manrup? The vertical line test. Oh, wait, let me use a better color. The vertical line test. What happens right there? It hits 2, doesn't it? Or does it? Bronwyn, why doesn't it hit 2? Open circle. That's not there. So this is a function. It's a special type of function called a step function. It's how cell phone companies used to bill you. Up to a certain amount of minutes or texts, you paid this much. Any more, you pay this much. Any more, you pay this much. It's how BC Hydro continues to bill your parents for your electricity. If you don't use very much, you pay less. The more you use, the more you pay, in an effort to keep you using less power. So, that's out of the way. What's the domain? Where does it start? Right there. What is that? -6. Is -6 included? -6 is not included, so square bracket. Oh, sorry, yeah, round bracket. I was looking at the next one. Now, here's where kids start screwing up. It gets to -3, right? Yeah. And then it hops up to here. But it starts again at -2.99999, doesn't it? Yeah. So it continues on. Even though the line shifts, the inputs continue solidly up until 6. Is 6 included? So what kind of bracket is it? Square. Does everybody get that? And of course, if you were writing it the other way, it would be -6 less than x less than or equal to 6. Even though the line breaks, We only care about domain, and it's solid. Did it just die on me? Son of a mother. $4,000. That's one word for it. Hey, we're back. And now, what about the range? Can I use this for the range? Patricia says no. Why not? Because the range isn't a line anywhere, is it? It's just 3 dots. So the range has to be 3, 6, 9. Is everybody cool with that? And if you were following along at home right now, you would do page 294 from your outline. 4, 6, 7, 8, 9. Now listen, please. Listen, please. I'm going to shut up in a second. I'm not even going to make you do work because I talked a long time. Listen for a second. Math class and physics class both use graphs like this. Physics deals with real life. Math deals with models of real life. Understand the difference. If I jump off a building, right? Or a cliff into water, what are the 2 things that are being counted? Height and time, correct? When I jump, my height starts going downwards as time passes, right? Eventually I hit the water. My height can't go any lower, can it? No. You can't measure below the water. And time cannot go backwards, can it? This is physics. That is real life. In math class, you guys know there's another side to that curve. Okay? This over here is math class. I do, I have 2. Somebody stole one of my hole punchers! Sons of bitches. Is there one back there? No, I used to have 2, Ewan.